Welcome back. So we saw the three parts for adding a new file system. So in part one, we saw that we needed to either add a new physical hard drive or USB to an actual machine or a virtual machine. In part two, we booted up Linux. And we saw that there was a new device file there. Linux was installed in SDA, and we had a new hard drive SDB, and then we partitioned it, and then we formatted it. And in part three, we made that file system accessible, and we make it accessible through a special directory called through a mount point. So what we're going to do now is we're just going to go through the whole thing. We're going to do a quick overview of the entire procedure for creating a file system and see how it all fits together. And then we'll take a quick look at your test for this afternoon. So if you go down Learning Path, you'll notice that I've uploaded the presentation. It's a PDF file, and you can follow along in that PDF. All right, so here is a typical way of dividing up a hard drive. So you can imagine this is a physical hard drive. If you've never seen a physical hard drive before, let me quickly show you what it looks like. Here is an image of one, and this is the long-term storage in your computer. This is where the files and operating systems are stored. And it's an old one because it has a disk that spins around and it slows it down. The newer hard drives are referred to as SDD or solid-state hard drives, and they don't have any moving parts. They're just microchips. So whenever possible, you want to buy a computer with a solid-state hard drive and not a spinning disk. So we want to divide up that storage area, and here's a typical scheme. We see that part of it is reserved for Linux. So you can see here the division, 9 gigabytes. And the device file for it, in this case it's HDA1, but that's an older hard drive technology. You're more likely to see SD instead of HD, so this is more likely to be SDA1 for that partition. Then you have some free space that you can use later, and this swap partition here, this SDA5, this is virtual memory. Now, your computer also has RAM, and that's the working memory, whereas the hard drive is the long-term storage. When you run out of RAM, okay, you're opening up programs, you're loading up your operating system, you use up all your RAM, then Linux begins using a space on your hard drive, and that's called the swap partition. So that might be called, a typical name for it might be SDA5. Now, the whole hard drive is not going to have a number associated with it. The device file would be SDA, and the individual partitions would be numbered, SDA 1, 2, and 3, and so on. A long time ago, we used to have these multi-operating system schemes on a hard drive. This is a bad idea. You can see here we have Linux on a partition. We have Windows installed on a different partition, and so on. We wouldn't do something like that today because hard drives are inexpensive, and we would install Windows onto a separate physical hard drive, and we would do that for performance reasons. We would get a faster computer if Linux was on one hard drive and Windows was on a separate physical hard drive. And the names of the files. Now, if we're talking about hard drives, the first hard drive is going to have the letter A associated with it. The SD is a reference to the newer hard drive technology, which is called SATA. Your second hard drive is going to be SDB, your third hard drive SDC, and so on. The partitions, on the other hand, they're going to be numbered. So for example, the first partition on your second hard drive would be SDB1. Okay, and that's how it would work. If it's the third hard drive and the fourth partition, it would be SDC for the third hard drive and 4 for the fourth partition. So that's what the letters and the numbers mean. Just remember, when you're representing the actual hard drives or USB storage devices, there's no number, and when there is a partition, there will be a number associated with those devices. So we took a look in the dev directory. Here I did ls inside dev, and we could see here SDA, that's the hard drive, and SDA1, SDA2, that's partition 1 and partition 2 on the first hard drive, and likewise with SDB, that's your second hard drive, SDB1 and SDB2 for the partitions. And there are many other files in the dev folder. We call them device files. They're used, they represent the devices on our computer, and in other courses we'll go through some of these other devices and device files, corresponding device files. Keep in mind, if you're using USB, it's not necessarily going to be referred to as SDA or SDB. The device file would have a different name and different location. So, and that of course depends on which version of Linux you're using. And what are we doing here? Well, we saw that in Windows. Let me quickly return to Windows here and click on Computer. Okay, we saw that we access the file systems by drive letter. So the C drive, okay, that's a partition right there, and that letter makes it accessible. D drive makes this device, my optical or DVD, available, and if I plug in a USB, it's going to be an E drive, and so on. Things are a little bit different in Linux. In Linux, we don't use drive letters. We use directories called partitions. So if I had a CD attached to this system, I would have a directory somewhere where I would access it. Instead of a drive letter, D or E, I would come to this directory here, CD-ROM, and that's how I would access it. And that directory can be anywhere. And part of what we want to do here is make a decision about the best places to put that mount point or directory. So we refer to these directories as mount points, and just think of them as the Linux version of drive letters. There's nothing deep going on. One is not better than the other. Just in the Windows world, we're going to have a drive letter associated with every file system. And in the Linux world, Unix world, it's simply a mount point or directory. And we have different systems for organizing our files and directories. And think about it like this: if you just throw everything in your closet, all your clothes and all your shoes, and you're not going to be able to find anything. So we organize our closet. We create a system within our closet so we can find everything. Likewise with a bookshelf. We don't just throw all our books on the shelf. We organize them, maybe alphabetically, by author name, by title name. We do the same thing with the files and directories. We need a system. And there are many of these file systems that are available. I'm only going to point out 4 of them to you: Extended 2, Extended 3, and Extended 4. That's usually what we format a hard drive with. And the difference is Extended 2 is prone to disk corruption. We can get corrupted file systems and corrupted files. And Extended 3 and Extended 4 has a mechanism to prevent that disk corruption, and that mechanism is called journaling. So if you lose the power, there's a power outage, your computer gets unplugged, you're more likely to recover from that kind of error using Extended 3 and Extended 4. The difference between Extended 3 and Extended 4 is Extended 4 is a more up-to-date version of Extended 3, supports larger file systems. I think Extended 3 only goes up to about 4 gigabytes in size, whereas Extended 4 can be in the order of magnitude of exabytes, way beyond anything we'll ever need. So Extended 4 is the best file system for partitions on hard drives. Don't bother with Extended 2 and 3. And ISO 9660, that's for optical media, for CDs and DVDs. These other ones you see right here, they're not terribly important for us in an introductory course in Linux. We may take a look at them later, but for now, the ones we're going to be using: Extended 4 for hard drives, ISO 9660 for optical media like DVDs. Okay, and then after using FDisk, okay, to create the partitions, we're then ready to mount the device. So first, take your device file. In our case, it's going to be SD, not HD. HD is for the older hard drive technology. So this is the third hard drive. We see HDC, ABC, so it's the third hard drive, and it's the fifth partition. And what are we doing? We are MKFS, so we're making a file system. This is called formatting, and we're formatting it with Extended 3. The -T there just means specify the type of file system, Extended 3. Okay, so it's been formatted. All right, we now have a filing system there. We have a system for putting files and directories there. Now we create a directory. Okay, how are we going to access HDC5? In Windows, we would use a drive letter, C drive, D drive. In this case, we're going to create a directory called data. You can choose any name you want. In this particular example, it's called data. And then look at this. We're going to associate the two. This file system, HDC5, is going to be mounted or associated to the data mount point or the data directory. And we do that with the mount command. So we type mount, Extended 3, specify the file system. You can see where the file system is located, HDC5 inside dev, and it's going to be associated with data. Now, you should do a few verification steps here to make sure that it was done successfully. Type mount by itself, and then go to the very last line, and that will tell you if you mounted it. And here we can see HDC5 has been mounted to the data directory, and the type of file system we're using is Extended 3. The R and W means it's read and write. We can see the files inside HDC5, and we can write to, and we can create new files there, delete files. We can change it because we have the right permission. And then finally, we have a command here for doing the same task on a CD-ROM. Okay, it's very similar. We're specifying the type -T, and remember, in optical media we use ISO 9660. The -R here just means it's read-only, and there's a mount point. Arbitrary, can be any mount point at all. And to finish off the overview, we're going to review the difference between MTAB and FS tab. So when you type mount, remember we typed mount here, it showed us our currently mounted devices. That's stored in MTAB. But when we boot up Linux, a bunch of file systems get mounted, and that's read from the FS tab file.